Alright, so we're continuing example 1. Example 1 said, what is the sum of the even integers from 2 to 100? So, in order to find a sum of a set of numbers, we were looking at a formula that we created yesterday. What was our formula that we created yesterday? So we have n divided by 2. And then what else was in that formula? A sub 1 plus a sub n. And what did each of these things mean? What was that n value? What did that represent? That represented our number of terms. So the number of terms in our series. What was this A1 value? It's our first term. And then what was our AN value? Our last term. So those were the three things that we needed to know in order to use this formula. So we want to use this formula in example 1 because we're summing all the even integers from 2 to 100. So if we wrote out just part of our series, we start at 2, because it says that we're going from 2 to 100. And we're summing the even integers. So what would our next even integer be? 4, 6, and then so on, all the way until we got to 100. So that's kind of what our series would look like if we wrote it out. So there's a lot of numbers in between this 6 and this 100. And we would have to add all of those up by hand. So this formula gives us a shorthand way of doing it. It's quicker. So in order to use this formula, we just said that we need an n value, we need an a1 value, and we need an an value. What values do we know right now, given the information from the question?
A1.
What's a1? 2. It's our first term here. What else do we know? So we know that 100 represents our a sub n value, because that's our last term. That's where we're ending our series. Do we know our n value?
No.
90.
So what?
Is it 100? If you're doing your ends.
So, okay, so is it 100? So we have to think about what we're adding. So we're summing up the even integers from 2 to 100. So if we went from 2 to 100, there would be, 100 digits, but we're looking at just the even ones. So there would be 50, because half of your integers from 2 to 100 are going to be even, the other half are going to be odd. So we can, for this one, we can tell that n is 50. Now if we didn't know that we had 50 terms, we would have to figure out what term that 100 is. We would have to ask ourselves, what term is this? Because that's essentially what we need for this n. This n tells us that we have 50 numbers. So 100 is our 50th term. But if we didn't know that, we would have to figure out what term 100 is. Do we have a way of figuring out what number that term is? What other formulas do we know for arithmetic stuff? The what? So we know the explicit formula. What's the explicit formula? So a sub n equals
A sub 1
a sub 1 Plus.
N minus 1 times D.
N minus 1 times D. So that was our explicit formula for finding terms in an arithmetic sequence. Well, now we want to solve for n. So this n in our explicit formula gives us the number of terms, and that's what we're looking for, right, is the number of terms. So can we use this equation to solve for this n? To solve for our n for this series? Because you already gave me some information. We know what A1 is. We know what our AN is. So can't we plug that stuff into this explicit formula? They represent exactly the same things. So what's our AN then? That 100. What's our A1 value?
2.
Is 2. We're solving for n. And then what's our D value?
2.
2, because we're adding 2 each time. That's the pattern. So then this should look like just a regular algebra type problem that we know how to solve.
You gotta distribute the 2, right?
So we have to distribute the 2.
2 n minus 2.
Okay?
And then you do, 2 cancel out and you divide by 2.
We combine like terms. We have a positive 2 and a negative 2, so they end up canceling out. So we get 100 equals 2n.
You divide by 2 and 50.
And then we divide by 2, so we get 50 equals n. So that's a way of actually showing that it equals 50. So if you're not sure, you can always check. This one, like I say, is kind of one that you can figure out, because half of your numbers are going to be even, half are going to be odd. They're not all going to be like this. You're going to have to know how you find that n value. So now we have our 3 things that we need to plug into our equation to find the sum. So now we're going to plug those in. So we're going to have 50 divided by that 2. And then we have our first value, which is 2, plus our last value, which was 100. So we're going to have 25 times 102. And 25 times 102 is 2,550. So if we add all the even integers from 2 to 100, it's going to equal 2550. So that's just being able to use that formula. All right, so we're going to move on to example 2. And example 2 gives us that it wants us to find the sum of the finite arithmetic series, which is 4 plus 9 plus 14 plus 19 plus 24 plus ...
9.
all the way to 99. So we need to find the sum of that series.
We have to find the pattern, don't we?
So
Plus 5.
Yeah.
So our pattern is plus 5. So we know that this is arithmetic. It told us in the problem that it was arithmetic, but if we wanted to make sure, that's the pattern. So to find the sum, again, we're going to want to use our formula. So those 3 values again that we need are that n value, that A1, and that AN value. Those are the 3 variables in our equation, or in our formula. So from that series, what values do we know? So what's A1?
4.
A1 is 4. Do we know anything else?
AN.
We know AN is 99. Do we know our N value? No. So how are we going to find our N value?
Plug it into the formula.
So we're going to, which formula?
AN equals A1 plus N minus 1 times D.
So we're going to use that explicit formula again. So what are we plugging in?
For AN, 99.
AN is 99.
A1 is 4.
A1 is 4.
N minus 1 times 5.
And our D was 5. So again, we're going to solve this for N. So we're going to have 99 equals 4 plus distributing that 5. So we end up with 5N minus 5. We can combine our like terms. So we get 99 equals 5N minus 1, because you have a negative 5 and a positive 4. We can add that 1, so we're going to get 100 now, equals 5N. Divide by 5,
20 equals N.
we're going to get that 20 equals N. So now we know our N value. Our N value is 20. So now we can just plug it into our formula. So we've got 20 divided by 2. Our A1 value is 4. Our AN value is 99. And then we solve this.
1030.
So we're going to get 10 times 103, which gives us 1,030. So if we added up all of these numbers in this series, it would equal 1,030. All right, and then our last example is a story problem. So we're told in this story problem that a salesperson, or that a company pays a salesperson a $10,000 bonus if they, at the end of their first 50 weeks, if they make 10 sales in their first week. So they have to make 10 sales in their first week, and then they have to improve their sales numbers by 2 each week thereafter. So each week after that first week, they have to increase by 2. So then we're told that a salesperson qualified for the bonus with the minimum possible number of sales. So they started with 10, then they increased by 2 each week until they got to their 50th week. So we want to know how many sales this salesperson made in week 50 and how many they made in all 50 weeks. So we have to answer 2 questions. The first question we have to answer is how many sales they made in week 50. So before we look at how many sales they made in week 50, let's look back at the problem again. We're given that they have to make 10 sales in the first week. What would that 10 sales in the first week represent? It's going to represent our A1 value, because that's week 1. They made 10 sales. Then we're told that they have to improve their sales numbers by 2 each week after that. So what does that mean? If they have to improve their sales by 2 each week.
Our common difference is plus 2.
So the common difference, our D value, equals 2. So if we wanted to write out a little bit of our series, or our sequence, however we want to write it, we would start with our first value, and then what would our second value be? It'd be 12 because we're adding that 2. Then how many sales would they have to make in the third week? 14, and then that would continue until week 50. So that is what we're looking for, is how many sales they would have had to have made in that 50th week. So how do we find a specific term? Which equation? So we're going to use the explicit equation again. That was how, for an arithmetic sequence, that was how we found a specific term. So in this case, we're looking for sales in week 50. So what are we solving for? We're looking for the number of sales in week 50.
AN.
So we're solving for AN. But more specifically, what's our N value going to be?
49, 50.
It's going to be 50, because basically this is giving us our 50th term. So we're looking for A sub 50. That's what we're solving for. So you guys told me that our A1 value was 10. So what's our N value? It's 50. We're looking for A sub 50. So our N value, our 50th term. That's what we're looking for. And then you guys told me also that our D value was 2. So now we're going to solve this for A sub 50. So we get 10 plus 50 minus 1 is 49 times 2. So we're going to have 10 plus
98.
plus 98,
850 equals 108.
which gives us 108. So that tells us that our 50th term, or the number of sales that this salesperson would have had to have made in week 50, is 108. So now, our second question is, how many sales did they make, or did this person make in all 50 weeks? So we're no longer looking for just this 50th week. We want to know how many sales they made in all. So, if we want to find out how many sales they made in all, what do we have to do with this series? Because now we can put in that this goes to 108. We know what that last term is. So we were just writing out the sales before, right? We were writing this as a sequence. But if we want to know how many sales they made all together, what do we have to change? So we have to take the 10 sales that they made in the first week, and we have to add the second week, add the third week, and continue adding until we get to that last week. So we have to add up all the sales. So now, instead of looking at a sequence, we're looking at a series. We're summing all of those values. So in order to sum all of those values, what do we have to do?
And
We have to add them. Are you going to want to add 50 numbers though?
no.
So what's the easier way to find this sum?
Put it in the formula.
Put it into this formula. This n divided by 2 equals a1 plus an. Or times a1 plus an. So again, we need that a1 value, we need that an value, and we need an n value. Do we know all of those values?
A1 is 10.
A1 is 10. It's still our first term.
AN is 108.
AN is 108. That's what we just found. The sales in week 50. And then what's our n value?
50?
And then our n value is 50. We have 50 weeks, so we have 50 different terms. So then we're going to plug this into our formula. So we're going to have 50 divided by 2 times 10 plus 108. So we're going to end up with 25 times 118, which equals
2950.
2,950. So in order to qualify for this $10,000 bonus, this salesperson has to make 2,950 sales in their first 50 weeks. All right. Now we're going to get into writing these series in a different notation. We've been writing them out like this, that we've got our terms and we're adding them. Now we're going to look at kind of a condensed version of how to write these. So in your notes, you see this new symbol. It kind of looks like a weird E. Well, that's called a sigma. It's a Greek letter. And what it means is to sum up. So when we're talking about our series, we're talking about summing up our terms. So when you see this symbol, this means that you're summing up some terms. Now, if you look, there are certain things around this symbol. In the example in your notes, you have an n equals 1, there's a 4, and then there's this n. Well, you need to know what each one of these things represents so that you can find the sum. So this n minus 1, or this n equals 1. What did our n represent before? What is our n always represented when we've been talking about these sequences and series?
Number of terms.
So n is always denoted our number of terms. So this n value is no different. This still denotes our number of terms. So when this says n equals 1, it's talking about the first term. And then up at the top here, these two things go together. This n equals 1 and this 4. They go together. This tells you that you're starting at your first term. So you're starting at n equals 1. So this gives you your starting point also. Or your starting value. And then what this number up at the top, or this 4 in our case, this 4 tells you what you go to. It's the value that you go to. Or like where you end. So in this case, we're going to take terms from 1 to 4. So we have 1, 2, 3, and 4, right? Are our numbers that we could plug in? Or our terms that we would have? Then we have this n. Now this n is going to be an equation or a formula. Now I know here it just looks like an n. It's not always going to be just an n. It's going to change depending on the problem that you have. So it's gonna be an equation or a formula. What that's gonna tell you is how we find our terms. So before, with a series, we were given our terms. So we were adding like 10 plus 12 plus 14. Now we need to find those terms. And that's what that equation is going to do. What we're going to do with this equation is these terms that you're given out here, this n equals 1 to the 4, you're going to plug those numbers in to this formula or equation. So in this case, we're starting at n equals 1. So this sum is telling us that we need to sum up the numbers from 1 to 4 when we plug them into this formula. So if we plug a 1 into this formula, what do we get out? If we plug 1 into n, are we doing anything to it? We just get our 1 back, right? So, and then we're going to 4. So then we're going to plug in a 2. So here we plug in a 2 for n. What do we get?
2.
2. And remember, we're summing. So 1 plus 2. Then we go to 3. We plug a 3 in. So we get plus 3. Then we're going to 4. So we plug in a 4. So this sum is the same as this sum. This is just actually written out. So if we're looking to solve this sum, we would add them up, and we would get 10. So this is kind of just a real basic one, just to get you familiar with what each of these means. So this is where you're starting, and we always start with our first term, so this n should always equal 1. You should have n equals 1. And then you're going to whatever your ending term is. So you have to know how many terms you have in your series. This is going to be the final term, or how many terms you have. So like in our previous example, we had 50 weeks, we had 50 terms. So in that case, this number would be 50. And then this is an equation or a formula that we're going to have to find so that we can find each of our terms. So we're going to actually look at example 4 because it'll make it a little bit clearer. So we're given the series 1 plus 4 plus 7 plus ... plus 31. And it wants us to write that series using this summation notation.
The difference is plus 3.
So our common difference, we're adding 3. All right. For this summation notation, we know that we're going to be writing it with that summation symbol, that sigma symbol. So we know we're going to need that. Now we need to find these 3 other parts. So we have our n equals our first term. Remember, n is always going to equal 1 at this bottom part. You're always starting with your first term. So then we have to find this top number. This top number, I said, represents how many terms you have in the series. So we have this series. Do we know how many terms we have in that series?
4.
We have 31.
4.
31 is our last term.
4.
Well, we have 4 that we can see, but there's a bunch in the middle there. So we know that 31 is our last term, but that's not this number that we're going to put on top. These numbers that you're putting in here for n aren't actual terms. They're the number of your terms. So you start at your first term, and then you go to however many terms you have.
So we have to plug it into the explicit formula.
So we have to plug it into the explicit formula to figure out what term this is. So you need to ask yourself, what term is this? So we use the explicit formula. So what am I solving for in our explicit formula then?
We're solving for a for n.
We're solving for n. This is what we're solving for. So what am I plugging in then? What an value am I plugging in?
31.
So I'm plugging in 31 because I know that that's the term that I'm looking for, what number it is. What's my a1 value? It's 1. That's my first term. I'm solving for n. And then you guys told me that my common difference, we were adding 3. So now we want to solve for n. So we have 31 equals 1 plus, we're going to distribute that 3. So we get 3n minus 3. We want to combine like terms. So we're going to get 3n minus 2 because we have that positive 1 and that negative 3. So then we're going to add 2 to both sides. So we're going to get 33 equals 3n. Divide by 3, you get 11 equals n. So what does that n tell us then?
N equals 11.
So n equals 11, so that tells us that this 31 is our 11th term. So what are we going to do with that 11 now? Why were we finding that?
Put it in front of the sigma.
Hmm?
Put it in front of the sigma.
So we're going to put it on top of the sigma. So we're going from our first term to the 11th term, which is going to get us to that 31. So in this case, we're going from 1 to 11. Now the part that confuses everybody, we need to find this equation or the formula that's going to go right here. So in order to do that, we're going to use that formula, we're going to plug in these n values, right? So is there some formula that I can use that I can plug in an n value?
N/2.
So there is the summation formula. Do I have another formula? Travis, you're shaking your head. What other formula do I have? You don't know? So didn't I just use another formula right here? So we're going to use the explicit formula again. Now this is like what we did in the warm-up yesterday when we solved for that nth term. This is why you need to know how to solve for that nth term. We're going to take our explicit formula. So we have our an equals a1 plus n minus 1 times d, right? Well, we want to write this in a way that we can plug in these n values. So we're going to be finding our terms. So we're going to be finding our AN values. So we want to write this formula in a general way that'll find all of our different terms. So if we want to solve for AN each time,
do 1 plus
do we know what our A1 value is?
1.
One.
Our A1 value is still 1. It's still our first term. And then because we're solving for AN generally, we're not plugging in an N value right away. So we want to leave that N alone. But then do we know our D value?
3.
Our D value is 3. So now, we can leave this formula like this, but it's kind of messy. So is there a way that we could simplify this? So we can distribute the 3. So we have 1 plus 3n minus 3. And then what can we do?
3n minus 2.
Then we can combine like terms and get 3n minus 2. So this general way of solving for AN is going to become our formula that we're going to plug in. So that's our last part for this summation notation. And if you want to check to make sure that this formula actually works, plug in 1. We're going to get 3 times 1 minus 2, which gives us back our 1. Plug in a 2. 3 times 2 is 6. Minus 2 gives us that 4. So this formula is going to give us back that series. So this series can be written in this summation notation. It's just another way of writing this series. So we'll look at example 5. I want you guys to try to do example 5 on your own.
So the answer is 3 and 9.
So this whole thing is
That's
your
the answer.
Yes. So I want you guys to try doing number 5 on your own. Travis, you can go ahead and stop that.